So this first one, you're supposed to use substitution. So I see that this has a coefficient of 1. So I want to solve for that x. Everything else has a coefficient of like 7, 3, 4, so that'll make it harder. So if you have that opportunity, find one that has a coefficient of 1, it makes it easier. So x minus 7y equals negative 18. Add 7y to each side. So x equals 7y minus 18. So now you're going to take that part that you just solved for, so 7y minus 18, and you're going to plug it in for x on the second one. So now you're going to have 4. We're replacing the x with 7y minus 18 plus 3y equals 21. So times the 4 in, that makes 28y. 4 times negative 18 is negative 72 plus 3y equals 21. So 28 plus 3y makes 31y, minus 72 equals 21. Add the 72 over. So 31y equals 93. So now to get the y all by its lonesome, you divide it by 31. And so y equals 3. Now that you have what y is, you can come back up here where it says x equals. You have x equals 7 times 3 because we replaced y with 3 minus 18. So 7 times 3 is 21 minus 18. 21 minus 18 is 3. So we have x equals 3 and y equals 3. If you put it as an ordered pair, that's your answer. So in the next one, I'll show you both ways that you could do this just in case you do it on the test. I'm going to solve for y on the top at first. So I have x minus y equals 6. I minus the x minus the x. Negative y equals negative x plus 6. So positive y equals a positive x minus 6. So now I'm going to take this and I'm going to replace the y on the second one with that. So I have 3x squared plus x minus 6 equals 8. Just a side note, if this would have been a minus, make sure you put this in parentheses so you remember to distribute your negative. So I have 3x squared plus x, and I'm going to minus the 8 over here. Minus 14 equals 0. So now this factors to be 3x plus 7, x minus 2. 3x times x makes 3x squared. 7 times 2 makes negative 14. So if I solve these, I get x, 3x equals negative 7. X minus 2 equals 0, so I add the 2 over x equals 2. So I get that x equals negative 7/3 and x equals 2. So now you know what x equals. You've got to figure out what y is as well. So y equals 2 minus 6 because x is 2. So I've replaced this 2 back into this value right here. So 2 minus 6 is negative 4. So when x equals 2, y equals negative 4. That's one solution. Now I'm going to figure it out for when x equals negative 7/3. So y equals negative 7/3 minus 6. So I'm going to turn 6 into thirds. So I multiply top and bottom by 3, that's 18. So negative 7 and negative 8 make negative 25/3. So when x equals negative 7/3, y is negative 25/3. So that's one way to do it. Just in case if you're factoring, so in case you're factoring it using the box method, you remember you take the first one, the 3x squared, you put it in the first upper left-hand corner. Negative 14 goes here. 3 times negative 14 is negative 42. So you're trying to find what multiplies to be negative 42 and adds to be 1. So 6 times 7 makes 42. If that's a negative, 7 minus 6 makes 1, so I can put those in here. 3 and 6 are divisible by 3, so that's a 1x. That's a negative 2. And 1 times 7 is there. So that's where I get 3x plus 7 and x minus 2, if you're wondering where I got the factoring stuff from. So the other way to do this problem is you could solve for x instead. So if you solve for x, you're going to add the y over. You have x equals y plus 6. So then when you come down here, you can have 3 parentheses y plus 6 squared plus y equals 8. So since you have y plus 6 quantity squared, you've got to do that first. So you have y plus 6 times y plus 6. So you have y squared plus 6y plus 6y plus 36, which makes y squared plus 12y plus 36. And you still have that all in the parentheses with the 3 on the outside. So that makes 3y squared plus 36y plus 108 plus y equals 8. So that's this y and that 8 right here at the end, y and 8. So that makes 3y squared plus 37y, so 36 and that. And then I'm going to minus the 8, so minus 100 equals 0. So if I use the little box method, 3y squared, negative 100, so it has to multiply to be negative 300, add to be 37, so multiply to be negative 300, so I'm just going to go here, negative 300 divided by x, enter, second table. So these are the things that multiply to be negative 300. So I'm looking for some that add to be 37. So 6 and 50, that's getting closer. Still not there. Oh, so they both have to be negative. Hold on. Pause. So, no. So one's positive, one's negative. So yeah, so we're looking at the right thing. So 50 minus 6 makes 44. Something's not working out right. Hold on. So I found my mistake. That's supposed to be a positive 100. So then that's a positive 300. So then when I go back to my calculator, they're all positives. So now I'm looking for two numbers that combine to make 37. So that's 40. The 10 and the 30 make 40. 12 and 25 make 37. So there we go. 12y and 25. So 3 goes into both 12 and 3. So 3 times 12 makes 4. That's a 1. 25 and 100 is 25. So this factors to be y plus 4. Sorry, that's a mess over here. I messed up in that beginning. So 3y plus 25. So now I get y equals negative 4. Y equals negative 25 thirds. Then you're going to plug those back in for y into this original equation up here at the top that we had, x equals y plus 6. So x equals negative 4 plus 6, which makes 2. And then I'd have x equals negative 25 thirds plus 6. So I'm going to turn 6 into thirds, so I times that by 3. So that's 18 thirds. So negative 25 plus 18 makes negative 7. So either way that we do it, x equals, either way that we do it, we get the same answers, negative 25 thirds and negative 7 thirds, xy and xy. So again, you can do it either way. I think the way that I did it first is a little bit easier because then I don't have to do all the squared stuff, but you'll get the same answer if you do them right. Question number 3 says use elimination. Much easier problem. Multiply this by 3, multiply this by 4 if you want to get rid of your y's. If you wanted to get rid of your x's, you'd multiply this by negative 2 and that by 3. So either way, you'll get the same answer. I'm just going to get rid of the y's since that's how I started. So 9x plus 12y equals 33. 4 times 2x is 8x. 4 times negative 3 is negative 12y. 4 times 13 is 52. So that's 17x equals 85 divided by 17, and x equals 5. So now I've got to take what x equals and plug it back in. So 2 times 5 minus 3y equals 13. So I replace that x with 5. That's 10, so I minus 10 from each side. So negative 3y equals 3 divided by negative 3, and y equals negative 1. So you can put that as an ordered pair if you'd prefer. Make sure I can find your answer is the big thing. Number 4, same thing, use elimination. I'm going to get rid of the y's again. I don't know why I choose the y's, but I do. So that's 3, that's 2. So that's 9x minus 12y equals 54. 8x plus 12y equals negative 20. So 17x equals 34 divided by 17. So x equals 2. Now I plug that into either equation. I'll plug it in the bottom one just for fun. 4 times 2 plus 6y equals negative 10. So that makes 8 plus 6y equals negative 10. Minus the 8. So 6y equals negative 18 divided by 6, and y equals negative 3. So I have x equals 2, y equals negative 3, or you could have 2, negative 3. Again, circle it so I can find your answer and know what you're trying to say is your solution. So on number 5, you're using elimination. Notice that x is already gone on this equation. So I'm going to get rid of x with these two. So I'm going to multiply all of this one by negative 2. So I have 2x minus 4y plus z equals 11. Negative 2x minus 4y minus 6z equals negative 18. So I hurry and do a quick double check. Negative 2, negative 4, negative 6, negative 18. So my x's go away. Negative 4y and negative 4y make negative 8y. Negative 6 plus 1 makes negative 5. Negative 18 plus 11 is negative 7. So now I can combine these two equations because they're each missing an x, and I've used all 3 of them. This answer came from the first 2, and this is the third one. You must use all 3 equations, okay? So I'm going to combine these 2 together. So I have 3y plus 5z equals 12. Negative 8y minus 5z equals negative 7. And I don't have to do anything with those because the z's are both 5 and one's positive, one's negative. That goes away. Negative 5y equals 5 divided by negative 5, and y equals negative 1. So now I can plug that into either of these 2 start equations to get what z is. So I'm going to take that negative 8 times negative 1 minus 5z equals negative 7. So 8 minus 5z equals negative 7 minus the 8. Negative 5z equals negative 15 divided by negative 5, and z equals 3. So now I have y and z. I have to plug it back into one of these that have the x's so I can figure out what x is. Now I'm going to use that middle one. So I have x plus 2y plus 3z equals 9. So I'm going to replace the y with negative 1. So 2 times negative 1 plus 3 times z, which is 3, equals 9, and x plus that. So 2 times negative 1 is negative 2. 3 times 3 is 9, equals 9. So 9 minus 2 is 7. So I minus the 7 over, and x equals 2. So you can write your answer as x equals 2, y equals negative 1, z equals 3. Or you can use an ordered pair, negative 2, 1, 3. So again, on number 6, I see that this one's missing a y. So I'm going to combine these 2 to get rid of the y as well. So I multiply this by negative 2 so that that turns into a positive 2y. And then I see a negative 2 and a positive 2 would cancel out. So the top one stays the same. The bottom one I'm multiplying by negative 2, so negative 4 plus 2y plus 2z equals negative 6. You could have just combined these and got rid of the z's. If that would have made you happy, that would have worked out as well. Either way works. So negative x, the y's go away, plus 3z equals 10. So I'm going to use the start equation and this equation. I'm going to combine them, and I'm going to get rid of the x's or the z's. So here's my two equations. So I'm going to multiply this bottom one all by 5. So I have 5x minus z equals 6. Negative 5x plus 15z equals 50. So I have 14z equals 56. So I go to my calculator, I go 56 divided by 14 equals 4. So z equals 4. I plug that into either of these two start equations. That start equation, there you go. So I plug that into either one. Doesn't matter which one. I'm just going to do the negative x plus 3z equals 10. So negative x plus 12 equals 10 minus the 12. Negative x equals negative 2, so a positive x equals a positive 2. So now I need to figure out what y is, so I plug it into one of these two that have the y. So I'm going to plug it right into this yellow one. So 2 times x minus y minus 4 equals 3. So 4 minus y minus 4 equals 3. So 4 minus 4, those cancel out. Negative y equals 3, so y equals a negative 3. So there's my y, there's my x, and my z. Or you could put it in an ordered pair, which is much easier to see all your answers together and easier to grade. But anyways, so that's the answer. If you look on my pretest on the answer key that I put on, you'll see that I did it a different way, and you can look and see how that worked out as well. So on number 7, it says x is greater than 0. So x is greater than 0 is here. So greater than is to the right, like 1, 2, 3, 4, 5. Those numbers are bigger than 0, so I shade that way. Y is greater than or equal to 0. So which numbers are bigger than 0? 1, 2, negative 1. So the ones going up are the ones greater than 0. So I shade above that line. So that's the answer to 7 and 8. So on number 9, you need to solve for y first. So you subtract x. So 3y is less than or equal to negative x plus 12. Divide it by 3. Y is less than or equal to negative 1/3 x plus 4. So that means on our graph, we're going to start at 4. So 1, 2, 3, 4. Go down 1 over 3. Down 1 over 3. Down 1 over 3. Down 1 over 3. It's a solid line because it's less than or equal to. So you connect those dots. And there's your line. So y is less than all of this, so that means these values y are smaller. If you wanted to check it, I pick a point anywhere. 0, 0 works. If I plug 0, 0 in for y and x, so is 0 less than or equal to 4? That's a true statement, so that means that point is part of the solution set. So therefore I would shade where it is because it's part of the part that worked. If I'd have chosen a point up here, it would not have been a true statement, and so I'd have shaded on the other side. So that's a different way to look at it as well for shading. Now I come to this next problem. I need to solve for y, so I minus the 3x over to each side. So 2y is less than negative 3x plus 15. Divide it by 2. So y is less than negative 3 halves x plus 15 halves. So 15 halves is 7.5 roughly. So I come to my graph, 1, 2, 3, 4, 5, 6, 7.5. You really ought to put little numbers on here like 1, 2, 3, negative 1, negative 2, negative 3. That way I know what you're counting by. Then I'm going to go down 3 over 2. So down 1, 2, 3, 1, 2. Down 1, 2, 3 over 1, 2. 1, 2, 3 over 2. You can keep going like this for as long as you want or until you run out of paper, whatever one. Connect your dots. Supposedly connect your dots. Now it says less, oh, so since this was a less than, not equal to, those should be dashes. So suppose you do this on your test and you use pen, just write to the side of it, dotted or something, right? Dotted, and that way I know that you understand that it's supposed to be dotted and not connected. And then it says less than, so that's shaded to the left, because those are the y values that are smaller. If I look at these y values are bigger than these y values, so less than is underneath. So looking at number 11, I realize that these are the same numbers as what you had on 7, 8, 9, and 10. So I'm just going to hurry and write down what these uh, equations were. So I've written down what the problems were. Now I'm going to graph all of these. So x is greater than 0 and y is greater than 0, just so you've already seen these. Um, you know that those two combined are only in this quadrant. So I'm only really looking in this quadrant. So now I'm going to graph these ones. So I come up here to plus 4, down 1 over 3, down 1 over 3, down 1 over 3. Solid line. Shaded below. So that's in here. And then this one, 15 halves. So that was 5, 6, 7 halves. Again, you should write numbers on these so that I know what you're talking about, so that somebody could walk up and be like, oh, this is where those are. So anyways, make sure you do that. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. So dotted. Shaded below. So the only place where these are intersecting is this area right here. And that's the intersection point. If you want to be super good and help me out a lot, you'd put this point is 3, 3. This point is 0, 4. This point is 5, 0. And this point is 0, 0. So I did a quick look at number 12 and I realized those were the exact same equations as what we've just graphed. So I know that there's a 3, 3, there's a dot. 4, 0, there's a dot. At 5, 0, there's a dot. So this was the shaded region that I'm looking at. So anyways, I know those are my points. Now, it says find the value for z equals 15x plus 12y. And I have 0, 0. So what I'm going to do is I'm going to have 4 problems. So I'm going to have z equals 15 times 0 plus 12 times 0. So that's using the origin right here. I'm going to have z equals 15 times 0 plus 12 times 4. So that's the first point going up. Then I'm going to have z equals 15 times 3 plus 12 times 3. So that's this point. And I'm going to have z equals 15 times 5 plus 12 times 0. So again, I just pulled that back from this question right here. So to save time, I made that the same. So 0 times 0, anything is 0, so that's just 0 plus 0. 15 times 0 is 0, 12 times 4 is 48. 15 times 3 is 45. 12 times 3 is 36. 45 plus 36 makes 81. 15 times 5 is 75. So my maximum value is 81. and it occurs at 3, 3. My minimum value is 0, and it occurs at 0, 0. And so that's your answer for number 12. So 13 says use substitution. I look at these, there's not anything that's not going to be a decimal when I solve for a fraction. So I just choose one. I'm going to solve for y on this first one. So I minus the 2x minus the 2x. 5y equals 11 minus 2x. This is about how the first question on your test looks. And so I wanted to make sure I had one on your pretest that looked similar to it. So that's what y equals. So I plug that in for the y on my bottom. So I replace the y with this 11 fifths minus 2x fifths. So I realized that elimination would be much easier, but I want you to use substitution. If you don't, you'll get the 2 points for your correct answer, but you won't get any other points for your work. So now I distribute this to both of those. So I get 4x minus 33 fifths. A negative times a negative makes a positive. 6x over 15 equals negative 4. So now I can combine the x's, or whoops, not 15, that's 5. So you might want to just get rid of all the fractions, and you could just multiply everything by 5. You could get common denominators of 5, or you could work with the fractions, whatever you want to do. So these two will give me the equivalent equation here as soon as I do it. So 5 times 4 is 20x. So remember, once you get common denominators, you can just get rid of all the denominators. So 5 times 4 is 20x. 5 times 33 divided by 5, well, those 5's cancel off. Leave me with negative 33, which is the same as here. 5 divided by 5, those cancel off and leave me with 6x, which is what I have here. And negative 4 times 5 is negative 20, which is what I would have had up here if I'd have distributed that to there. So either way, you get the same answer. They're just different ways of going about it. So 20 plus 6 is 26x. I add the 33 to the other side. 33 minus 20 is 13. Divide it by 26, and x equals 1/2. So now I'm going to plug that into the top equation. I could have used the other one. I just chose the top one. So 2 times 1/2 plus 5y equals 11. Half of 2 is 1. Plus 5y equals 11 minus 1 minus 1. 5y equals 10. Divide it by 5, and y equals 2. So x equals 1/2, y equals 2. There's the ordered pair, or there's writing it in variables. All right, so you're supposed to use elimination on this. I'm going to combine these two to get rid of the z's. I could have got rid of the x's. You could get rid of the y's. Let's just get rid of the y's since we haven't done that. Let's get rid of the y's. Those are already set up. So if I add those together, I get 4x plus z equals 6. So those are combined. Those went away. 3 minus 2 made 1. 16 minus 10 made 6. So that's good. So the y's are gone. I'm going to combine these two. I could have combined the top one and the bottom one as well, but it has to be the top one and one of the other ones. And I'm going to get rid of y as well. So that means I've got to multiply this by 2 and that by 3. So that makes 4x plus 6y minus 2z equals 30. 3x minus 6y plus 9z equals negative 30. That's an interesting idea. So I get 7x plus 7z equals 0. So now I can take these two equations and work with those. And since they're both missing y, I can work with them now and just solve like you've been doing the other problems. So I'm going to multiply the top one by negative 7 so that the z's go away. So I get negative 28x minus 7z equals negative 42. So that makes 21x negative equals a negative 42. Divide it by a negative 21, divide it by negative 21, and x equals 2. So now I'm going to plug that into one of these starred equations. So I'm going to do the 4x plus z equals 6. So 4 times 2, because that's x, plus z equals 6. So that's 8 plus z equals 6 minus the 8 over, and z equals negative 2. So there's my x, there's my z. We need to figure out what y is. So y is up in one of these three. I'm going to use the middle one. So I have x minus 2y plus 3z equals negative 10. So x is 2 minus 2y plus 3z, so 3 times negative 2, equals negative 10. So 3 times negative 2 is negative 6. 2 plus negative 6 is negative 4. Minus 2y equals negative 10. Add the 4 over. So negative 2y equals negative 6. Divide it by negative 2. And y equals 3. So 2, 3, negative 2. So 51 in your book says create the equation of a quadratic that goes through these 3 points. So remember, this is x and this is y. So I'm going to have 3 equations replacing these x's and y's with these coordinates. So y is 6, a we don't know, but we know x is 0, b times 0 plus c. So anything times 0 is 0. So this goes away and this goes away. So I get that c equals 6. Now on the next one, y equals negative 6, a times x squared, x is 2, plus b times x, which again x is 2, plus c, which we know is 6 because we just found that on the first equation. Now on the last one, y is 9, x is negative 1 squared, plus b times negative 1 because that's x, so we're replacing the x with negative 1, plus c, which is 6. So now I'm going to work with these 2 equations, and I'm going to simplify them down. 2 squared is 4, so I have negative 6 equals 4a. So negative 6 was the beginning. 2 squared is 4, so 4 times a. 2 times b, plus 6. So I'm going to minus the 6 over. I get negative 12 equals 4a plus 2b. Now on the bottom one I have 9. Negative 1 squared is 1, so 1 times a is just a. b times negative 1 makes negative b, plus 6. So now I minus the 6. So I have 3 equals a minus b. So I now have 2 equations with 2 unknowns. So I'm just going to write them next to each other to make it easier to see. And so now to get rid of this b, or I could get rid of the a's, I'm going to multiply all this by 2. So that makes 6 equals 2a minus 2b. So if I combine it with the top one, which this is the top one, the b's go away. 12 minus 6 is negative 6. 4 plus 2 makes 6. So I get the a equals negative 1. And then I'm going to plug that into either one of those 2 starred equations. I'm going to use this one. 3 equals negative 1 minus b. Add the 1. So 4 equals negative b. So b equals negative 4. So my final answer is going to be y equals a, which is negative 1 x squared, plus bx, but b is negative 4. So I'm going to change that plus to a minus. So negative 4x and 6 goes in place of c. So that's the answer for that problem. 65 is the same idea as 51, but more challenging. These are my x's, these are my y's. So I have 2 squared plus 2 squared plus a times 2 plus b times 2 plus c equals 0. That's my first equation. My next equation is 6 squared plus 0 squared plus a times 6 plus b times 0 plus c equals 0. My last equation, 7 squared plus negative 3 squared plus a times 7 plus b times negative 3 plus c equals 0. So I now have 3 equations with 3 unknowns. I'm going to simplify them down. 2 squared is 4, another 2 squared is 4, so that makes 8. So I have 8 plus 2a plus 2b plus c equals 0. So now I'm going to minus the 8 over. So I have 2a plus 2b plus c equals negative 8. So that's the first one. The next one, 6 squared is 36. 0, 6a, no b's, plus c equals 0. So I minus the 36 over. So I have 6a plus c equals negative 36. Now the last one, 7 squared, negative 3 squared is 9, plus 7a minus 3b plus c equals 0. 49 plus 9 is 58. So I minus the 58 over. So I have 7a minus 3b plus c equals negative 58. So now it's just back to the same kind of problems we've been working with. Notice how this one doesn't have a b with it. So I'm going to multiply all this by 3 and all of this one by 2 and get rid of the b's, and then I combine that answer with the middle equation here. So that makes 6a plus 6b plus 3c equals negative 24. Down here on the bottom I have 14a minus 6b plus 2c equals negative 116. So I have 20a plus 5c, negative 24, and negative 116. That makes negative 140. And my middle equation is 6a plus c equals negative 36. So I'm going to multiply all of that by negative 5. So that makes negative 30a minus 5c, 36 times 5 is 180, equals a positive 180. So that's kind of been replaced with that. So 20 minus 30 is negative 10a. 180 minus 140 is 40. Divide it by negative 10, and a equals negative 4. So now I can plug that into the middle. So 6a plus c equals negative 36. So 6 times negative 4 plus c equals negative 36. So that's negative 24. Plus c equals negative 36 plus 24. And I get that c equals negative 12. So now I can plug that into any one of these three that has a b to figure out b. So I'm going to plug it in the top one. So 2 times a plus 2b plus c equals negative 8. So 2 times negative 4 is negative 8. Combine that with negative 12 makes negative 20 plus 2b equals negative 8. So now I add 20. 20 minus 8 is 12 divided by 2. Oops, divided by 2. And I get that b equals 6. So there's b, there's a, there's c. So now I come up here to my equation. So I have x squared plus y squared minus 4x plus 6y minus 12 equals 0. So that's my equation. If you read the book, it says write this in standard form. So if we do that, I'm going to need some more space. If you remember, that's when we complete the square and do all that fun stuff. So we're going to put our x's together, x squared minus 4x plus y squared plus 6y, and we're going to move the 12 over to the other side. So half of 4 is 2, half of 6 is 3. We square them and add it to each side, so 4, 9, 4, and 9. So then this factors to be x minus 2 squared plus y plus 3 squared. And over here we have equals 25. So the center of my circle is at 2, negative 3 with a radius of 5. So anyways, that's a pretty long process to get to there, but that's what that problem is. So I've been trying to keep the video under 30 minutes. You can see that I'm well above that. I was trying for 40, but it's going to be above that too. So anyway, sorry it's a long video. So on this one, see how there's no x in the middle? I'm going to combine the top and the bottom to get rid of the x's, so multiply that by -1. So I have x plus 2y plus 4z equals 3. Negative x plus 2z equals positive 7. So I distributed that negative. The x's go away. I have 2y plus 6z equals 21. Make sure I multiplied that right. X plus 2y plus 4z equals 3. Negative x plus 2z positive 7. Oh, add those, not multiply. There we go. That looks better. So now I have this equation from the middle. If I multiply it by 2, I get 2y plus 6z equals 10, which is exactly the same as the one on top. So if I multiply this all by a negative and combine them, everything goes away and I get 0 equals 0, which means there are infinitely many solutions. If you get that far, you'll get full credit. If you want to try to get some extra credit, here's how you do that. So I'm going to take this equation in the middle, y plus 3z equals 5, and I'm going to say let z equal a. So now I have y plus 3a equals 5 because I've changed z to a. So I minus the 3a over. So now I have y equals negative 3a plus 5. So I have z and I have y. So I'm going to plug that into one of these two. I'm going to use the bottom one because it's going to be easier. So x minus 2z, which is a, equals negative 7. So now I add 2a to each side. So x equals 2a minus 7. So my ordered pair is 2a minus 7, negative 3a plus 5, and a. So on infinitely many solutions, this is what you can do. So the last question, this is a circle. Remember, this is a circle with a center of 2, 1, radius of 3. So 2, 1, radius of 3. So you place your dots, connect them into circle fashion. I was trying to cheat and use the little compass tool, but it didn't want to come up. Absolute value, remember this is the opposite of what it says in here, right 3, up 4. So to graph that, I go right 3, 1, 2, 3, up 1, 2, 3, 4. So it's right there. And since it's got a negative in front of it, it goes down. So that's like a negative slope, down 1 over 1, down 1 over 1, down 1 over 1. Continues on like this forever. So now the circle, I need to find out if I shade inside or outside of the circle. So I pick a point, 0, 0 is inside of my circle. So if this point is correct, that means I would shade inside. If this is not if this point does not make a true statement, I'd shade outside. So 2 squared, negative times negative makes a positive 4. Negative 1 times negative 1 makes a positive 1. So 5 is less than 9. That is true. So I would shade inside my circle. So the inside of my circle is all shaded. Okay. So I guess I can hurry and do that. So inside of my circle is shaded. Now, my absolute value, I'm going to pick the point 0, 0. So 0, 0, y is less than negative absolute value of negative 3 plus 4. Absolute value of negative 3 is 3. Or the absolute value of negative 3 is a positive 3, but then the negative on the outside makes it negative. 4 minus 3 is 1. Forgot my y value in here for 0. So is 0 less than 1? That's a true statement, so I would shade down below. So the only place where these two intersect is right here. So that's the solution. You could have shaded outside of here as well, trying to show that, yeah, you understand that it was everything in here plus the circle, but the only place that they meet is that area right there. Real fast, I'll try to show you on the calculator how to do this. So the first thing to do on the calculator, your calculator won't graph this part. So you actually have to solve for y, which is really a long process. So I minus this over, so I have 9 minus x minus 2 squared is less than y plus 1 squared. So now I take the square root of this. So that's the square root of 9 minus parentheses x minus 2 squared. And that gets rid of the squared on, so I took the square root of each side. So now I have y plus 1, so I'd minus the 1 over here. So really what I end up with is y is less than or equal to negative 1 plus or minus this. Okay. When you do the negative case, you have to switch to the inequality. So really that's the positive case. The negative case is this. Okay. So I go to my calculator, go to y equals, make sure you change that. Your buttons are going to be different than mine. This is the old version because my new one doesn't have it. So negative 1 plus the square root 9 minus parentheses x minus 2 squared. Then I'm going to come down here, change my sign, greater than, negative 1 minus second square root 9 minus parentheses x minus 2 squared. And then I need the third one. So now the third one says negative absolute value. So you go math, number, abs, x minus 3 plus 4. Then you're going to graph. So there's the top half of the circle. There's the bottom half of the circle. Here comes the absolute value. I'm going to hit alpha shades on mine. Yours is different. It brings up the same menu if you find the right spot. Inequality, intersection, and I hit enter. And that's going to clean up my graph and show me the places where they intersect. So see how it's cleaning it up. Now here comes my absolute value line. Apparently I didn't draw mine as good as I could have. So anyways, that's the idea of what you should have. So, or else I forgot something on my. So anyways, that's what it should look like.